Imagine you're standing on a hill, looking up at a night sky full of twinkling lights. You might think you're seeing a whole bunch of tiny flashlights glued to a black canvas. But what's actually between those lights? Spoiler, it's not just darkness. It's the most mind-boggling, ginormous, and surprisingly empty real estate in the universe. So what is space? Grab a cup of coffee, or a spacesuit, if you fancy, and let's dive into the cosmic equivalent of an empty attic, but one that stretches for billions of light years. Defining the void. When scientists talk about space, they usually mean the region beyond Earth's atmosphere, where the air we breathe gives way to a near-perfect vacuum. But calling it empty is a bit like calling your junk drawer clean. It's technically true, but there's a lot of hidden stuff going on. First, let's clear up a common myth. Space isn't completely empty. It's filled with a thin soup of particles, radiation, and fields. Think of it as the universe's version of a low-fat broth, so thin that a cubic centimeter might contain only a handful of atoms, but still enough to keep physicists up at night. One of the first formal definitions came from the Fédération Aéronautique Internationale, FAI. They drew the Kármán line at 100 kilometers, about 62 miles, above Earth's surface. Below that, you need a plane. Above that, you're officially an astronaut. It's a neat line, but nature doesn't really care about our paperwork. The atmosphere gradually thins out, blending into what we call the exosphere, and finally into interplanetary space. A brief history of the void. Humans have been staring at the sky for millennia, but the idea of space as a physical place is surprisingly modern. Ancient Greeks, like Aristotle, believed the heavens were a series of concentric crystalline spheres, no empty void between them. It wasn't until the 17th century, with telescopes peering at the moon and planets, that thinkers like Galileo and later Newton started to imagine a space that could exist on its own, independent of Earth. In the 20th century, the term outer space entered the lexicon, especially after the launch of Sputnik in 1957. Suddenly, the void became a frontier, a place you could actually visit if you had the right hardware. The word space itself comes from the Latin spatium, meaning distance or room. Fitting, because that's exactly what it provides. Room for planets, stars, galaxies, and of course, your imagination. The space right above us. Let's zoom in on the layer just above our heads. The atmosphere gradually thins, but it doesn't just stop at the Kármán line. The thermosphere, for instance, stretches from about 80 kilometers to 600 kilometers. That's where the International Space Station, ISS, orbits. Even there, the air is so thin that a human would suffocate in seconds, but it's thick enough to create drag, slowing the station down ever so slightly. Above that lies the exosphere, which fades into the solar wind, a constant stream of charged particles blown out by the sun. This region is the first taste of true interplanetary space. It's also where we start to see the cosmic microwave background, CMB, the afterglow of the Big Bang, peeking through the leftover radiation. If you've ever heard the phrase, space is a vacuum, you're not wrong, but it's a vacuum with a twist. It's not a perfect void. There are photons, light particles, neutrinos, and even occasional atoms wandering around. It's the universe's way of saying, I may be mostly empty, but I'm never completely lonely. Interplanetary space. The sun's backyard. When we talk about interplanetary space, we mean the region between the planets of our solar system. It's dominated by the sun's influence, the solar wind, magnetic fields, and a constant rain of charged particles. The solar wind travels at speeds of about 400 kilometers per second. That's roughly 1 million miles per hour, creating a bubble called the heliosphere that shields the inner planets from galactic cosmic rays. Now here's a fun fact that might make you chuckle. The solar wind is essentially the sun's exhale, and it smells, if you could smell it, like, well, astronomers think it smells a bit like burnt toast, because it contains trace amounts of carbon and oxygen. Not that you'd want to get close enough to take a whiff. Interplanetary space also hosts the asteroid belt, the Kuiper belt, and countless comets. These icy and rocky relics are leftovers from the solar system's formation, floating in a region that's mostly empty, but dotted with ancient building blocks. It's like a cosmic yard sale, where the items are millions of miles apart, and the price is measured in astronomical units. If you're enjoying this cosmic ride, hit the like button, and don't forget to subscribe for more out-of-this-world content. Let's keep exploring together. Interstellar space, beyond the sun's reach. Once you cross the heliopause, the boundary where the solar wind slows down and gets compressed, you step into interstellar space. This is the realm between stars, the true void that makes up most of the volume of our galaxy, the Milky Way. The interstellar medium, ISM, is a tenuous mix of gas and dust, with an average density of about 1 atom per cubic centimeter. To put that in perspective, a decent vacuum chamber on Earth can achieve a density that's lower than that. So in many ways, the best laboratory vacuum on Earth is actually dirtier than the average interstellar space. The ISM isn't uniform. It's a tapestry of hot, warm, and cold regions. The hot, ionized gas, heated by supernova explosions, can reach millions of degrees, while the cold molecular clouds are the birthing grounds for new stars. It's a place where the leftovers of dead stars mix with the ingredients for future suns, a cosmic recycling center that never closes. Intergalactic space, the vast between. Step even further out, past the edges of the Milky Way and other galaxies, and you enter intergalactic space. This is where galaxies themselves are like isolated islands in an ocean of almost nothing. The density here is even lower, roughly 1 atom per cubic meter, which is about as empty as any environment we can observe. Yet intergalactic space isn't completely deserted. It contains the intracluster medium, ICM, a hot X-ray emitting plasma that fills galaxy clusters. It also holds dark matter, an invisible scaffold that gravitationally binds galaxies together. Without dark matter, our Milky Way would be a far less cohesive place, and we'd probably have drifted apart eons ago. And then there's the cosmic web, a giant network of filaments made of dark matter and gas, connecting galaxies across billions of light years. It's the universe's way of playing connect the dots, but the dots are galaxies, and the lines are invisible to the naked eye. The observable universe. How far can we see? Now let's talk about the ultimate horizon, the observable universe. Light has traveled for about 13.8 billion years since the Big Bang, and that gives us a sphere of about 46 billion light years in radius. Within that sphere lie roughly 200 billion galaxies, each containing billions of stars. But here's the kicker. The universe is expanding. The distance between us and faraway galaxies is increasing, meaning that the light we see today has been stretched or redshifted into longer wavelengths. The most distant objects we can observe, the so-called first galaxies, appear to us as they were just a few 100 million years after the Big Bang. It's like looking at a baby picture of the cosmos. What lies beyond the observable universe? Honestly, we don't know. It could be more of the same, infinite galaxies, stars, and planets. Or it could be something entirely beyond our comprehension. The universe might be infinite, or it might be curved in a shape we can't visualize. Either way, the answer is humbling. Dark matter and dark energy, the invisible players. If space were a cake, the atoms we're made of would be the frosting, a tiny, tasty layer on top. The rest of the cake is dark matter and dark energy, two mysterious ingredients that make up about 95% of the universe. Dark matter doesn't emit, absorb, or reflect light, making it essentially invisible. We infer its presence from the gravitational effects it has on visible matter, like the way galaxies spin faster than they should based on their visible mass. It's as if there's an invisible scaffolding holding everything together. Dark energy, on the other hand, is the mysterious force driving the accelerated expansion of the universe. Think of it as the universe's own dark side, a sort of anti-gravity that pushes galaxies apart, making the cosmic web stretch ever faster. Neither of these phenomena can be directly seen, but they shape the large-scale structure of space in profound ways. Why space matters, even if you're grounded. Now you might ask, why should any of this matter to someone sitting on a couch, scrolling through cat videos? The answer is surprisingly practical. Space research has given us GPS, weather satellites, memory foam, water purification, and even the smartphone in your pocket. But beyond technology, understanding space feeds our curiosity. It reminds us that we're part of something larger, something that stretches far beyond our planet. It inspires artists, philosophers, and dreamers. It challenges us to ask the biggest questions. Where did we come from? Are we alone? What's the ultimate fate of the universe? And let's be honest, space is just plain cool. The sheer scale, the mind-bending physics, the beauty of a nebula. It's a source of wonder that transcends borders and cultures. It's a shared human heritage that belongs to everyone, even if most of us will never get to float among the stars. So what is space? It's the near vacuum that fills the cosmos, the stage on which galaxies dance, the medium through which light travels, and the mystery that continues to puzzle scientists and dreamers alike. From the thin air above Earth to the vast intergalactic voids, space is both empty and full, empty of matter, but rich with phenomena, history, and possibility. As we continue to explore, we'll undoubtedly discover new layers, new questions, and maybe even new answers. The journey is far from over. It's just beginning. And the best part? You're already part of it. Every time you look up at the night sky, you're peering into the very space we've just talked about. If you enjoyed this deep dive into the cosmos, please hit the subscribe button, ring the bell, leave a comment with your favorite space fact, and share this video with friends who love a good cosmic mystery. Your support helps us keep exploring the universe, one video at a time. Bonus fact. And now, here's a bonus fact that didn't make it into the main script. Floating in the Milky Way, about 25,000 light-years from Earth, there's a giant cloud of alcohol. It's called Sagittarius B2, and it contains enough ethanol to fill billions of trillions of pints. So if you ever needed proof that the universe has a sense of humor, there you have it. Cheers to space.